So good afternoon, everyone. All the members, thank you so much for joining. I think this is the first monthly lecture of IASTA after this new committee has taken over for the IASTA leadership under the leadership of Professor Neeraj Rastogi and his team. So this monthly lecture will continue from now onwards towards the basically the last week of every month. So definitely there will be lot more intimation will be provided compared to this time. I think this is the first time after the executive committee has taken over. So for today we have a very important person, Dr. Ashish Tiwari, for the talk. I think which is very important, which will going to connect the policy, monitoring, and how the different strategic action based on the Airshed approach, how now he has managed several things in air pollution domain, and this will provide a very good opening lecture for the IASTA community as well as the air pollution community. I think I request formally to Dr. Manish Joshi to introduce our speaker for today. I think then we'll proceed.
Thank you, Dr. Sahu. So it is my pleasure to introduce Dr. Ashish Tiwari. He is led heading Action Area B, which is stimulating action for clean air across the Hindu Kush Himalaya, where he leads regional efforts on air quality management, and he has held this position since 2025. At IC mode, Ashish provides strategic advisory technical contributions including methods, frameworks, and new insights for policy making and air pollution monitoring to target the most polluting activity sectors and improve air quality. Dr. Tiwari is a serving member of IFS, Indian Forest Service, Government of India, and is on deputation to IC mode. Prior to joining IC mode, he has held several senior policy leadership positions within the government of Uttar Pradesh, including Secretary, Environment, Forest and Climate Change, Member Secretary, Uttar Pradesh Pollution Control Board, Member Secretary, Uttar Pradesh State Climate Change Authority, Member Secretary, Uttar Pradesh Environmental Impact Assessment Authority, and Director, Environment, Uttar Pradesh. He pioneered of Airshed-based approach to air quality management in India and has served as chairperson of the working group that prepared the detailed project report for the Uttar Pradesh Clean Air Management Project, India's first large-scale airshed-based initiative. His contributions have been repeatedly recognized through several honors, including the WWF PATA Bagh Mitra Award for Tiger Conservation in 2015. So we wanted to have one lecture which integrates research to policy making. So this is the perfect avenue to have this lecture. The title of the lecture is Clean Air for a Billion People, Bridging Science, Policy and Finance in Indo Gangetic Plain and Himalayan Foothills Airshed. So now it is my pleasure again to invite Dr. Tiwari to deliver his lecture. And we are very fortunate to have you, sir. Please go ahead.
Thank you very much, Dr. Joshi. Can you hear me clearly?
Yes.
Okay. Thank you very much, Dr. Joshi. Thank you very much, IASTA, for inviting me for this important talk. And I'll just take a minute for sharing my presentation, then I'll start. Just checking, can you see my presentation?
Yes, we can see your presentation.
Okay, thank you. So thanks again to IASTA, Dr. Neeraj Rastogi, Dr. Sahu, and Dr. Joshi. Thank you very much for this very important talk today. Then this topic is very close to my heart. And as like the title goes, clean air for a billion people. So we are all sitting in a very, you can say, global hotspot of air pollution, which is called IGPHF, Indo-Gangetic Plains, Himalayan Foothills, Airshed. I think I should not tell the scientific community what airshed is, but whether the air quality in Lahore, in Dhaka, Kathmandu, Thimphu, Delhi, the air quality is more or less same. When a crop residue is burnt in India, Punjab or Pakistan, Punjab, the impact of PM 2.5 and secondary aerosols goes even to the Bangladesh. So that is a, you can say, challenge which this global hotspot is facing. The annual average PM 2.5 varies between 8 to 20 times above the WHO norms. And air pollution is not only a health problem, it's economic, it has economic costs. And also the third angle of air pollution, which is related to black carbon, is like black carbon and short-lived climate pollutants, is the loss of glacial mass, which creates impact on water security and also creates vulnerability for disasters in downstream countries. So these are the few figures which you all know, that in our region there is a life expectancy loss of 3 to 5 years. Economic cost is basically 8 to 10% of regional gross domestic product per year. And the population which is affected is 1.9 billion, which is a quarter of the global population. So that is the kind of challenge this region has. The second challenge which this region has is the development. It's a developing region. So a lot of development activities you will find over here. And the population is also density is also very high. So on, you can say, the impact side, there is a great, you can say, the vulnerability. So this is the challenge. This is the region about which I would be talking about, and it's known as a global hotspot of air pollution. It covers across 5 countries, and ECMOD, where I am working, is an intergovernmental organization, and we are really very happy to work across all 5 countries because our mandate runs across the 8 countries, in which these 5 countries are included: India, Nepal, Bhutan, Bangladesh, Pakistan. So this region has all problems of air pollution, whether it is a problem related to science, whether the challenges related to policies because of geopolitical situation. You can see the kind of geopolitical situation this region has. The third, it is a developing region where you can say the environmental investments would always be facing kind of a competing commitments in other sectors like infrastructure, health, education. So financing for clean air in this region, in this developing region, is also a challenge. Then impacts on society and health. Environmental impacts we can all understand, but the societal impacts are also there. You can say the impacts on, you can say, the economies are also there. The impacts on water securities are also there. So you name any challenge related to air quality management, you would find this challenge over here. So now the Gordian knot, how do we plan to solve this problem of air pollution? So today I would like to put across not very, you can say, a technical kind of presentation. I think scientific community has done an excellent job, yeoman's job, in actually creating a very robust science around air quality management, air quality and pollutants and their transport and their modeling and whatnot. Everything has been done well by the scientific community. So really, you all have done a great job. But how do we translate this science into policies, and how these policies are implemented? What should be the strategy? I'm very consciously using this word strategy. What the strategy is? Strategy is basically something which we also plan out, which is beyond our control. Planning is something which we can do ourselves, but a strategy where we harmonize so many actors, so many actions, so many stakeholders, and so many spheres of, you can say, interventions. So what should be the strategy to solve this Gordian knot, this problem? So the global, based upon global experience and the based upon air quality management implementation, which we are seeing in the region since last maybe around 20 years, the strategy has to be designed. A very, very comprehensive strategy has to be designed. First of all, the global experience says that it should be long term, focused. Like, it should not be that National Clean Air Action Plan is there for 5 years, next time it is not there. So long term focus strategies is a need. We all understand that because of complexity, because of environmental impacts, because of societal impacts, because of economic impacts, because of competing commitments of the government for other sectors, the air pollution problem cannot be solved at the drop of the hat. We really have to build around long-term focused strategy. I'll tell how the other countries have done. Second is the robust national planning. Even if we want to talk about regional cooperation, like Airshed cuts across 5 countries, so the regional cooperation has to happen. But if we all 5 countries sit together and decide, harmonize our efforts, those efforts have to be grounded by the way of robust national planning and implementation. That is why we need robust national planning. I would ask a simple question whether India has a national emission inventory or not. So these are a few questions which will be taking up in due course of this talk. Third is the evidence-based policies and implementation. Like, I would always cite an example of fertilizer-related emissions. The whole world is behind the crop residue burning, but equal contribution comes from nitrogenous fertilizers, which are applied in the agricultural fields, the secondary aerosols, which atmospheric chemistry generates after that, ammonia emissions. That also contributes equally to crop residue burning. We have recently done a policy paper on that. So really, we have to go evidence-based policies, and we have to track implementation of the policies, whether our policies are implemented properly to deliver the desired result or not. Then, of course, the regional cooperation, because it's an airshed. So it's a 4-pronged strategy which the country should adopt to solve this Gordian knot. And it is easier said than actually doing this. How, that we'll see here. I'm just citing the global experience on long-term focus strategies. We all know the BTH, the China experience, Greater Beijing, Tianjin, Hebei region. They have reduced their PM 2.5 from 105 microgram per meter cube to 30 microgram per meter cube. That is a remarkable 71% reduction in about 12 years, 2013, and now we are at 2026. So as with Mexico City, it took 25 years. Santiago, 22 years. Seoul, 5 years. Of course, the problem was not that big in Seoul. Then Ulaanbaatar, Mongolia, that also has the same story. Bangkok also has the same story. So what I mean to say here, that if we take the global example, then we have to be very, very, we have to understand that clean air actions planning is a long-term process, with most successful cities achieving substantial pollution reductions through sustained efforts over 5 to 25 years, depending upon the gravity of the problem. Yeah. Then coming to the national clean air strategies, why do we need it? So we need national strategies because national strategies help us to integrate the things. I would cite here an example of whether we are able to integrate short-lived climate pollutants control strategy with our clean air strategy or not? Because the sources are common, the mitigation measures are common, the policies are common. If you are working on PM 2.5, you will definitely get a reduction in black carbon emissions. So are we able to integrate it? But when you do national level planning, you get this opportunity to think in an integrated manner. Then you can manage resources and impacts extend beyond administrative boundaries, because air, like Kathmandu Valley's air pollution, recently the Gaines model has given us insight that the contribution to Tarai region of Nepal to Kathmandu Valley's PM 2.5 annual average is about a quarter. So within the country also there are airsheds, micro airsheds. So at national level planning, you integrate the things, you harmonize, you synergize the efforts. Then you can establish a common vision, target, and priorities. Then you can align policies, regulations, investments across sectors to prioritize coordinated, cost-effective interventions. Like if there is a cost-effective intervention, then all the provinces in the country, all the countries in the region should take up together to prioritize, to strengthen accountability, and to harmonize regional air quality efforts. This is why we need national clean air planning. And I'm skipping this slide. And what should be, like we are working, I'll tell you how we are working in the region, but our vision for national clean air planning framework is basically a national emission inventory. Every country should have a national emission inventory. And the organization with which I am working right now, we are developing national level emission inventory for Nepal and Bhutan. And we could also motivate to the World Bank that national level emission inventory should be developed for Bangladesh and Punjab, Pakistan, which is the largest contributor in Pakistan to this airshed. So World Bank is supporting Bangladesh and Pakistan to develop national level emission inventory. So 5 of 4 countries will have national emission inventories maybe in a couple of years time. So our vision is that the whole region should have national level emission inventory, which are bottom up. The resolution 3 kilometer by 3 kilometer at least. Then there should be source apportionment. Like recently, we could mainstream the requirement of having super sites in Nepal. So under Nepal Clean Air and Prosperity Project, 3 super sites are getting established. So the source apportionment doing traditional way and the source apportionment in real time. Also, our vision is that we should have that next generation technology in place for supporting our decisions. So recently we have coordinated with Chinese Research Academy of Environmental Sciences, and we are establishing a super site in EC Mod headquarters, and it will be ready by September. Then the policy gap analysis, like policy is, like I work mostly in the policy sphere, it's basically a evolving field. If you have a policy today, that may become obsolete maybe after 2 years. So policies have to be responding to the environmental problems, the societal issues, the economic issues, etc. For instance, like today we are having electric vehicle and electric mobility policy, but after 20 years we will have to have the circularity of electrical and electronic waste, a very, very robust system in place. So maybe after 8 to 10 years we should start planning. So it's an evolving field. Like right now we are having import policy relaxation so that the cost of battery and everything comes down. But maybe after 10 years, we would focus upon the domestic manufacturing. So policy is an evolution. So evolving field, we have to really keep update our policy, always do gap analysis, understand how the policies can complement to the emerging issues and problems. Then sector specific planning, like we should take some sector specific challenges where not only policymakers but our solution providers, engineers, scientists should have worked together. I think somewhere down the presentation, we will discuss the Chinese experience also. We have been able to go and see on the ground because China being a member country of EC mode, so we have quite a strong collaboration to see what China has done in doing this wonder of reducing air pollution. So sector-specific planning is very much needed. And the very important thing is a very, very robust monitoring and evaluation framework with indicators. We all know the Sustainable Development Goal Index, which has done very good work, not at the global level, country level, and province level as well. So similarly, a monitoring and evaluation framework is needed. If country is small, then three level of maybe the agency level indicator, then sector level indicator, then national level indicator. Then if country is large like India, then we can have the agency level indicator, provincial indicators, then national level indicators, depending upon the country. But a robust monitoring system where auto fetching of data, the data sets are available, we can track the implementation of policies, we can take mid-course correction, mid-term course correction, etc. So that is very much needed. So I wanted to present here that this framework is needed if really we want to. And I am so happy that Nepal and Bhutan, these countries have come forward to have their national level strategy based upon this framework. And we are partnering with TERI and IIT Kanpur for these two countries. And by 2027 end, we would be able to complete this strategy work. And Bhutan has been pioneer. Of course, the air quality is not that bad in Bhutan, but they have a vision to comply with WHO norms by 2035. So we are working on that targeted vision. Here, I would not go into detail. This slide is very detailed, but what I want to say here that how we can bridge science and policy and financing. So 3-4 sectors I have taken up. Like science says that within transport sector, the biggest challenge is the heavy duty vehicles. But until recently, when government of India, I am taking India as example because you are all from India. Until recently, when government of India for NCR region has come out with a policy to basically fleet modernize the heavy duty sector, heavy duty vehicles segment. So there was no policy for heavy duty. There were only limited policy for urban mobility, electric buses and all. But the largest contribution was coming from the heavy duty trucks, freight vehicles, etc. So recently, so the evidence came from the science that within transport sector, largest contribution is from heavy duty vehicles. The Nepal also is coming up with a policy of retrofitment, emission control devices, etc. So their evidence is also working. The evidence is on use of fertilizer, the evidence is on invisible sources of pollution which are out of focus, the evidence is on urban-rural, you can say, relation in pollution. We think that pollution is only in the cities, but it's not like that. Even common people, they find it difficult to understand. They say that the villages are more cleaner, but when we explain them scientifically, then they start understanding. I would cite an example that when we were drafting this UP Clean Air Management project, so then we said in our highest level presentation in front of our political masters that largest contributor to air pollution in the state of Uttar Pradesh is from cooking. So nobody believed. They said, "Ki this is not possible. Your data is wrong." Then on a simple piece of paper, we have just made some calculations and showed them, then they started believing. So here, we should have evidence-based actions, number one, for transport sector, heavy duty vehicles I have, and the solution must be complementing not only to economics, not only to the country, but also to the society. I always take an example. If you come to Kathmandu, you will see the super emitters, all heavy duty trucks and buses. They emit black smoke. So ideally, we should stop them we should off-road them in one day. But can we do that? Is society ready to accept this challenge? Would the population in Kathmandu would not receive any, you can say, freight transport from India or from other country? So the life will become a standstill. So the society cannot accept this kind of a change. So here comes that our science actually should complement to this challenge. What could be the cost effective first step to reduce tailpipe emissions? Whether it is retrofitment, whether it is emission control devices, whether it is DPF, diesel particulate filter, and what, and how the government can catalyze. Government can catalyze, but unless you develop businesses around air quality management, nothing is going to happen. So this is how actually sector-wise we will have to take up our strategies. The countries which have done adopting this strategy have shown the success. Now I'll come to cooking. I have cited an example. The Nepal has done a wonderful work in Tarai region for household-based biodigesters. The adoption rate after phasing out of GCF project is around 60 to 70%. I am a policymaker. I have worked in the field. I have not seen such a good adoption of any intervention made by the government. I always say when in 1995 I joined Indian Forest Service, I saw the smokeless chulhas. And today also people are saying that fuel efficient stuffs, but adoption is not there. So great challenge is there. But when I came here and saw that household based biodigesters, adoption in Nepal, it's phenomenal. So this is how really we have to understand. Of course, LPG adoption will be there, but for LPG adoption, 100% India will take another 25 years. There are studies around that. By 2050, India will be fully having a full adoption of LPG. But what we do between 2025 and 2050, that is a scientific challenge. Here we will have to find out a solution which is cost effective, which has affordability, which is effective, and which is also easy to adopt by the community. So I'm not going into detail, but I am just putting before you the how actually we should strategize our sectoral actions. Here comes the industrial boiler sector. Like whole region, I have visited Bangladesh also, Pakistan also, India, I have worked there. The major challenge is micro, small and medium enterprises, the industries. When National Green Tribunal sent me as a member secretary of UP Pollution Control Board along with member secretary of Central Pollution Control Board to visit a polluting medium scale industry, and we saw that no function was working, then we just wanted to understand why your pollution control systems are not working. So young boy, after selling his property, he established this industry. He said, sir, if I operate this pollution control system, my product become very, very costly in the market. So my whole industrial proposition will become unviable for me. So that is a challenge which we should find out a solution. The solution is not to close down that industry, but we have to find a solution. The solution is like we should have common steam boilers for medium, small industries. We should have a policy in place where we should adopt a cluster-based approach, where all industries which use small boilers come up in a cluster, and steam as a service, like you establish a bigger boiler which can take even fecal sludge from sewage treatment plant as a feedstock, or crop residue or anything which will solve double problems as a feedstock. And if you have a bigger system in place, you will have a better pollution control devices, state of the art, and it will make an economically viable proposition also to run that system for a bigger industry. And steam as a service in our country, in Gujarat, is coming up very well. So we need that kind of a solutions. The problem-oriented solutions we have to need, keeping in mind the needs of the society. Our solutions should not only respond to environmental challenge, but also it needs to respond to societal challenges and also it needs to respond to developmental challenges of this region. Similarly, for agriculture, I have cited about the fertilizer use efficiency. So the countries which have done better in fertilizer use and they have achieved efficiency, their productivity and use of fertilizer is actually decoupled. But in this region, in all country, without naming any, the use of fertilizer is increasing, fertilizer by nitrogenous fertilizer, and the productivity is going down. So that kind of challenge really we will have to find out. It's a very, very you can say difficult area dealing with the farmers, but it needs behavioral change, it needs science, and recently government of India's PM Pranam scheme is actually if you use your fertilizer efficiently and the subsidy savings can be shared with the farmers, that is a wonderful scheme. But how that scheme gets implemented on the ground, that delivery system we need to develop. Similarly, about the waste, every city is facing problem of waste. The main problem which I understood after 15 years is why our systems are not working. Under Swachh Bharat mission, lot of investments have been made for developing huge waste management facilities. But those facilities, operation and maintenance have always been a problem. After making so heavy investment, the waste management facility of Kanpur was just lying like that. It was not functioning. So the problem is actually we receive unsegregated waste, and all our waste management facilities are designed for segregated waste. That is the problem. So can we have a technology where unsegregated waste can be treated or managed or processed? So that is the kind of thinking we really have to find out a solution. I am not a scientist, but whether I'm just thinking very loud that whether plasma gasification can solve this problem. So that is on one side. Second, can we link up our waste to co-processing of our cement kilns, etc., and can we put in place EPR mechanism to put more money in the waste management ecosystem? So these are few policy questions which need support of the science. Then comes the very important thing, which is financing. As I said, like developing countries, you will always have competing governments will say that, oh, I need money for infrastructure development. They will say, oh, I need money for health. They say, oh, I need money for education. We are a developing country. So how do you get financing for climate change and clean air? So there is a concept of green budget. We have tried this green budget in the state of Uttar Pradesh, where every scheme of the government is rated for greenness. How much greenness, green index is of that scheme. Supposing you are all sitting in Mumbai, there is a road construction project. So we can rate that this particular project has a green index of, say, 3 out of 10. But if that project takes a decision that we'll use only the low carbon cement, then the green index of that project will increase to 6 and 7. And then automatically more and more financing will be available for low carbon cement. So this is the example by which we can understand basically, and the green budget tagging is a very important tool, because for any climate action or clean air action, 60 to 70% of, you can say, financing comes from the domestic sources. So how we can actually leverage that? So this instrument, green budget tagging, is very, very important. So Nepal and Bhutan, this green budget tagging we are doing, and India, Uttar Pradesh has already done, and this is an year-on-year activity. So suppose I was working as Secretary of Environment, Forest, Climate Change. So green index of my department, including all schemes, we averaged all schemes of the department and did the green tagging of the department as well. And see, the green tagging of the department, forest department, environment department was X. So now next year you have to improve on your green tagging. So that decision was taken by, very wise decision was taken by our political masters. So year on year, there will be more and more finances available for clean air actions and climate actions. So this is one of the tools which we can use at the policy level. Then there are other tools also, carbon financing. Of course, the carbon market is very unstable, but still there are so many examples where carbon financing has done wonders, made the interventions economically viable. Other instruments also, like climate bonds, the green bonds, public-private partnership is also coming up very well. There is a one more, you can say, concept within public-private partnership is hybrid annuity. Like you hire a vendor for 15 years. He will construct and operate for 15 years, and his payment will be based upon the performance. So this we have tried with sewage treatment plants in the National Mission for Clean Ganga. So there, the STPs which were having problem of operation and maintenance, they started actually functioning up to the norm. And decision support system is a thing which is, I think, the way we have decision support system. I think Dr. Neeraj was there in Bangalore. There I also spoke about it, that the challenge with the decision support system, that the policymakers are afraid of using this. They think that I need a scientific backup to actually understand this, and this is a very complex thing, and they are not sure about the results, etc. So we are trying to build a model of models where at the front end it would be very, very simple for policymakers, but at the back end it would be having a great science. And this has been done in European Union, which is called Screening for High Emission Reduction, Potentials on Air Quality, Sherpa. We are now customizing this Sherpa tool, which is model of models, where you don't have to run scenarios every time, but the model scenarios are trained by different models, and at the front end it becomes very, very simple and it gives good result. So we are customizing it for our IGPHF region, and our vision is that at least by 2029 the countries will be started using that, and they will be benefited on both fronts, the evidence-based policy formulation and evidence-based tracking of policy implementation. So then comes the next generation of AQ monitoring, which is super site, and like we should have a real-time source apportionment. So that is the area where really we should go, and how we can bring down the cost of real-time, you can say, source apportionment. It should not be very costly. There are technologies which China is using. China at present has 16 super sites in this GTH region, and they are now integrated their stack emission monitoring data by SEMS to this super site, and finally they are coming up with real-time source apportionment that we have seen in Hebei province in the big data center, and drawing, you can say, knowledge from there. We are trying to replicate at a pilot basis for Nepal, Kathmandu Valley in EC mode. Then the most, you can say, difficult challenge for our region is the cost of AQ monitoring. In Indian rupees, still the cost of a reference grade monitor is 1 crore, and operation maintenance cost is 20 lakhs per year. So India should have, ideally, as per CPCB norms, around 2000 monitoring stations. But now, despite best of efforts, India could have only little above 600 monitoring stations. So a lot of areas are unserved. So how we can bring down the cost of AQ monitoring? Can we integrate satellite data, low-cost sensor data, and the reference grade monitoring data together to develop a high-resolution 2.5 maps through this kind of a hybrid monitoring system? If the cost come down, our served area and the covered area for AQ monitoring will be more, and we would be handling this problem. We all scientists the whole scientific community knows that what is the use of AQ data. So that is again a challenge with us, and we sincerely want to work on bringing down the cost of AQ monitoring. This is one of the biggest policy challenges in the region, IGPHF region. Then comes the last thing in the strategy is the regional cooperation. I think as a policymaker, not a scientist, when I visited US EPA in the month of April, I was there for 2 days, visited US EPA, saw the CLR trap intervention, understood it. Then my take from there was the regional cooperation has actually brought down the pollution levels in the region. So here is the example of Convention on Long-Range Transboundary Air Pollution. I visited US EPA and I saw what they have done. So they have actually worked upon with the countries, and 40% reduction in PM 2.5 has come down. Similarly, US-Canada Air Quality Agreement has also yielded similar results. And China has really made wonders in GTH region through regional cooperation only. So that is the strength of regional cooperation. These are the examples before you. And why do we need regional cooperation? Because, as I said, Kathmandu valleys receives pollution from Nepal Tarai within the country, receives pollution from India and other countries, and all our provinces in India, they also receive pollution from other regions within India, and every country has been impacted by. So this is the, you can say, science of airshed. So we really need we need a regional cooperation for air quality management. What we are doing for that? Today, the geopolitical situation is very difficult. We cannot have any convention treaty like CLR trap and like US-Canada air quality agreement or what China has done. So what should we do? So the EC mod with the World Bank and ADB, we started this thing, science policy dialogue. So in 2022, we started with science policy dialogue. At least our aim was to bring together the policymakers, academia, and scientists together and sit on the table and start talking about air pollution. That was the sole aim. And then it became an annual event. And 2023, we did it in Thimphu. There, a technical committee was constituted to understand the challenges of air quality management in IGPHF, etc. Technical committee meeting was also held in 2025. And in December 2025, finally, the countries have agreed on having a voluntary platform for regional air quality management. It's non-binding, non-legal, but voluntary, but bit often structured. So that draft the SPFD has prepared and sent to the regional member countries for their formal approval. So 2 out of 5 countries have already given their consent with little modification, and other 3 countries are also working. So we are quite hopeful that this voluntary platform in this difficult geopolitical situation will come up, and there we can actually have some things moving for harmonizing our efforts in 5 countries. And now this year, recently on July 20th, we have done a preparatory meeting for 4th Science Policy Finance Dialogue, where countries have come together to co-create the agenda for 4th SPFD. So they co-created the agenda, decided priorities, and in September, we are going to have 4th Science Policy Finance Dialogue, and we are quite hopeful that regional cooperation platform, the voluntary regional cooperation platform, will also see light of the day. So this was the journey, and this is the kind of regional cooperation platform we have proposed. There will be a steering committee at the top, which will be having representations from each country, federal level ministry, secretary level officers. Then this steering committee will give guidance to 3 thematic working groups. First is thematic working group is in air quality monitoring, second in solution, and third in finance. And now ADB is also on board with us. So ECMOD, World Bank, and Asian Development Bank, we together are like doing this regional cooperation. And ECMOD will work as a secretariat for this regional cooperation platform. So this we have proposed, and we are quite hopeful that this would see light of the day. So here I will stop. There are a few slides, but definitely this structured approach of dialogue and knowledge sharing and harmonizing policies at least would definitely bring down. And very importantly, I would like to go back to previous slide that Kathmandu, that Thimphu declaration, actually it's not a target, but the all country agreed on a shared vision of 35 by 35, 35 microgram per meter cube by 2035. So all countries agreed. So that was a big achievement. So now this whole voluntary regional cooperation platform is working towards designing policy, harmonizing, integrating to achieve that shared vision of 35 by 35. So I stop here. Thank you very much for patient hearing, and I will unshare my presentation. If you have any questions, then you are most welcome. Thank you so much.
Thank you so much, Tiwari. It was really very interesting talk, and I'm sure there will be multiple questions. So I would request audience to raise hand, and I can call them one by one. And meanwhile, people raise hand. Please allow me to ask one or two questions.
Yeah, sure.
So in the beginning, you were showing that some examples of some countries you were showing that where they reduce the PM concentration, either PM 2.5 or PM 10 by somewhere around 20 to 70% for different countries.
Okay.
So means have they used a similar uh, methodology to reduce that, or they are different? And if we have example in front of us, we can't simply means follow the same thing.
Yes, I think Dr. Rastogi, very true, because I cited about 6, 7 cities example. So there were cities also and the region also. The China example was a region. So the 3 provinces in China makes an airshed. So they worked on airshed, and the others largely worked upon the city level. So it's a mixed kind of learning, wherein like if there is an airshed impact, then we will really have to work upon airshed. So like our IGP HF is an airshed and very active airshed. Like meteorology makes lot of, you can say, impact on air quality. So there really we have to adopt airshed based approach, and uh, not only the airshed based but micro airshed based approach. Because if you go to Mumbai is an urban agglomeration. The municipality limits, there is equally bigger Mumbai just contiguous to that. So that urban agglomeration approach, the micro airshed approach. Otherwise, what happens? The agencies are different. In Mumbai, there is a Brihan Mahanagar Palika, and then outside that, there is some other agency. So there is no coordination. So that is why something like recent example of CAQM, Commission on Air Quality Management. So that is a kind of an organization which is coordinating with all agencies, etc. So I think it depends that what kind of challenges we have, but definitely we have to adopt a regional approach within the country and outside country as well.
So do you think here means one more thing you showed that at different places, local sources versus sources from other regions or other countries, to side they were varying a lot.
Yes,
So that means it should also depend. Means first we should know that for a given site, what are the actual sources, and then go for the way you are suggesting.
yes,
Just one more question, and then I will go to other people.
yeah,
One more thing you said that means we can for clean energy when you were talking about green energy, you were talking about we can switch from traditional stoves to electrical stove or to electric vehicles. But unless we have power generation by clean energy, means we can switch at one place, you can switch, but if we have thermal power plant, if electricity is coming through thermal power plant, then effectively I don't know means how much it will be um, helping.
Dr. Rastogi, very good question. I think the electric stove is like electric boilers and electric stove is very, very useful for Nepal and Bhutan like country, which has 100% hydropower in their energy mix. So here the renewable energy is very high, Nepal and Bhutan. So there I think electric boilers are more suitable. But in a country like India, where energy mix largely the power is coming from fossil fuel, there we should adopt the steam as a service model, which I cited, the renewable crop residue or the urban waste based steam generation system. And if we have a larger units supplying steam to several units, then the efficiency will also increase. Small boilers, the efficiency issues are there. The efficiency is very low. So there is a bouquet of technologies available. There is an electric boiler. There is a steam as service technology. There is a heat pump technology also. So the sectors like pharmaceuticals and food and beverages, where very high temperatures are not needed. Like food and beverages, they use temperature like 250 to 300 degree. And pharmaceutical also does not need very high temperature. So their heat pumps can be used. So we really have to choose the appropriate technology and see about its affordability, etc. before actually. So kind of a feasibility study has to be done.
Okay, so there is no uniform
No
policy. It has
uniform.
to be
No uniform.
means
Yeah.
custom made. Yeah.
Yeah.
Okay, let us go to the other people. Dr. Sahu, you can ask.
Okay, I think, am I audible?
Yes, Dr. Sau, I
Yeah,
can hear you.
yeah. Thank you so much for a very, very excellent talk. I think we got a very good overview of what really need to be done. But here I have a question, I always think is very important. Eh, You said that there will be a lot of collaborations required. I think in India we have all the scientists are working great, they're doing great job, but at the same time, the government, the implementers, I do not see there is a fundamental institutional mechanisms that really connecting all of them together to work effectively. Lot of things we are working on, so many things, getting very good scientific output, but these are remain inside our lab. So, however, I think if we can be utilize all this, there should be a feedback mechanisms altogether. Let's say, for example, if you want to do a interventions, so as you said that you put the monitoring framework to know whether this intervention is working or how much reduction it created. Such kind of mechanisms, feedback loop has to be there from top to bottom so that we can see how we can make a progress. So can you please make, you are very, very important positions. You have handled several question things. So what should be done to strengthen these mechanisms?
I think, Dr. Sahu, you are very correct in saying that. In fact, my whole presentation is focused upon the strategy, which is not only for scientists, it is more for the government. And this is what we are trying to inculcate in the minds of governments of Nepal and Bhutan. Because see what China has done. There you see the engineers are working in air quality management. They just identify a problem and they try to find out the solution. And the government is very, very responsive to the scientific community. And I think our science and technology policy of Government of India and the state government's policies, because recently you have seen that Commission on Air Quality Management, that body has started incorporating lot of scientific inputs in the policy making. So really you are very correct, this is a critical gap, I accept it. And this critical gap has to be bridged by establishing very, very accountable institutions within the government. But there is a ray of hope, Dr. Sahu.
Yeah.
Now all the state governments are now having by one name or the other, some transformation commission like structures. Like UP is now having a state transformation commission, which you can say is a Niti Aayog for the state. So now every state is looking towards like how we can actually solve the problems. So
Yeah.
there, I think from both sides, a step forward is necessary. I think what I did working in UP, a very small thing. It's nothing to praise, very small thing. I just made a road show in IIT Kanpur that look, this is our problem. What you can do for us? So then we got the responses and we got very good solutions for us. Like for industrial emission monitoring, I was not having that many engineers in pollution control board to check every industry. So I requested scientist community in IIT Kanpur, can you provide me a solution? Of course, SEMS is there, but sometimes the industry cannot afford SEMS because SEMS ecosystem is not built up. So they provided me very simple solution. You put a PTZ camera, which is 25,000 INR, in front of the boiler feed gate, and just have that live data on your server. So, and you can have create a sub circuit. I say ki they don't operate the air pollution control devices. What solution you have? Then a young PhD scholar told me, then you can have a sub circuit for air pollution control system, electrical sub circuit, and for that sub circuit put a smart meter. So if that smart meter is giving reading remotely, that means at least current is going in the air pollution control system. If he switches it off, then probably you can remotely know it. So this is how I am saying that key, of course, has to be some institutions where this knowledge sharing and problem oriented solution can be actually found out. This is a critical gap. We are trying to find out how this critical gap can be bridged by creating appropriate institutions. And you can say our monitoring thematic track would also take up issues of governance. These are all issues of governance which will be taken up. So, of course, lot needs to be done. Right
Yeah.
now, I don't have any solution which I can give you.
Yeah. Thank you so much. And thank you so much. Yeah. Others, you can go ahead. I have so many questions, but I will discuss in separately.
Yeah. We'll meet sometimes and have a
Yes,
good
I'll
discussion.
share some of the important papers on Airshed as well as we discussed that satellite, low cost sensor, and all these things to be integrated to identify the hotspot. By the way, I
Yes.
just wanted to share that last Asian Aerosol Conference, a student got the best thesis award for doing that work. No,
Okay.
so getting the identify the hotspot in Delhi using the satellite and local sensor work and
Very
integrating in
good.
machine learning model. I think I will share that information with you. Thank you
Please,
so
Okay,
much.
Mr. Sahu. Yeah.
in my team, Dr. Sahu, Mr. Ravi, Dr. Ravi Sahu is there, who is intervention manager monitoring. He is now working on this integrated system. So definitely we'll connect with you together sometime.
Sure. Thank you.
Thank you.
Okay. Now another hand was raised by Vaishnavi. Now she has lowered down the hand. Vaishnavi, you would like to ask?
Yes, sir. I would like to ask.
Please. Please.
Sir, sir, your talk was very knowledgeful. So I would like to ask related to the based on the biodigest that you have told that was implemented in Kathmandu. Sir, how can it be implemented in a country like India where still there are people, common people who are utilizing the traditional cooking methods? So how it will be like policy wise, how it can be implemented?
See, it's a very good question, Vaishnavi. The solutions for clean cooking. There are three basic challenges. One is affordability, whether because you are getting crop residue, cow dung cake, and you can say the fuel wood free of cost. But if as a government, if I go there and say that why don't you use this solution which has a cost? So there it becomes difficult. So affordability is one problem. Second is the behavioral change, whether they use that solution or not. What is their behavior? Behavioral change is a long drawn process. And third is the beliefs and disbeliefs attached to a particular solution. Like for gobar gas, which we call household-based biodigesters, people say that we will not eat the food which is cooked out of gobar gas. So that is a kind of belief and disbelief. I'm just telling you. So the solution which we can try and which Nepal has tried, they provided some subsidy for this household-based biodigester. Say, supposing the cost is 35,000 INR. So about 15 to 18,000 subsidy the government had provided. And there was a microfinancing institution also, which the Nepal National Bank has provided, enabled the small microfinancing agencies. And third, there was like so the upfront cost was lowered down very much. Very soft loan was provided, and finally the government support was also there. So they took up that, and every household has 3 4 livestock with them, so the cow dung is also available. Otherwise they will be using cow dung cake. And there was a very good ecosystem of local NGOs who have worked on health impacts, so they could actually show them that these are the health impacts. So slowly people started getting convinced, and this is how adoption took place. And now the scheme is phased out, but still after 2018 the scheme phased out. But in 2026, recently we have done a study, the adoption is around 60%, which is phenomenal. So this is how we can actually, and there are bouquet of solutions. It's not like household based biodigesters, but there are other solutions also recently, like of course the battery based solutions. Solar has a very high cost, because for electric thing the battery cost is very high. So those solutions may not work in India, but there is a one more solution which needs to be popularized, works upon the heat storage system, which is called Surya Nutan, developed by Indian Oil Corporation Limited. You can just Google Surya Nutan and see there is a plate which conserves heat energy, and with that heat energy, the food is cooked. So those kinds of, like, there are number of solutions, but definitely how those solutions are to be implemented based upon these three challenges. One is affordability, second is their behavioral change, and third is their beliefs and disbeliefs. Like tandoor, we say that gas tandoor is the best. And we have done a pilot in Lucknow where we have shown them that gas tandoor is more economical than coal-based tandoor. So, but the problem is Lucknow people, they prefer that smoky kind of that tandoori ka preparation. So for that also we found out a solution, that with a small pot, if you can put a charcoal burning, then that gives you even the same flavor, smoky flavor in the gas tandoor. So these are the beliefs and disbeliefs. हम लोग भी कहते हैं चूल्हे का खाना अच्छा लगता है. So that is a belief or disbelief, you can say. So we really have to, cooking is a difficult sector. We really have to work upon on these three fields. I hope I could answer your question.
So
Yes, sir. Thank you so much.
next. Yeah. M. Ashok William. Ashok.
Yes, sir. Good evening, sir.
Good evening.
Sir, thank you for your excellent presentation. And I want you have mentioned that 40% reduction in Europe countries in PM 2.5 in last 30 years, 25 years. Can I know what is the mitigation steps what they have took to reduce the PM 2.5?
See, the mitigation steps are basically they have worked on the sources. There is no solution other than working on sources. So Europe, if you see, they've started working upon industries, which were the prominent sources, and they've started working upon the transportation sector. These two sources they have worked, and if you really want to become low cost, low emission, industrial transition, they have worked upon it. So I'm not going into detail what they have done actually, but you have to identify the sources. This is what China has done, this is what Europe has done, and you have to really work upon the sources.
Okay, so
Thank
I
you,
think
sir.
no more raised hand, but there are two questions in the chat box. Let me read. I hope means it's okay.
Yeah,
You are
yeah,
not
it's
getting
okay.
late, huh? Okay.
No, it's okay.
So one question by Vaibhav Bangar. He brought up the contemporary topic. So he is asking to what extent does ethanol blending support or conflict with the objective of improving fuel quality as a strategy for reducing vehicle emissions and enhancing air quality? So E20, whatever means,
See, for ethanol blending, the biggest problem is the groundwater. I have a different perspective on ethanol blending. See, if you are manufacturing ethanol from sugarcane juice, then sugarcane is the very high water guzzling crop. And I have seen, because I have worked in Meerut as a district level officer, I have seen the blocks, developmental blocks, getting dark over the years because of sugarcane. So this ethanol blending has a very severe negative impact on groundwater, number one. Second, for like emission control for air pollution, I think BS6 standard is phenomenal. If we can modernize our fleet to BS6, battery electric vehicle transition is a distant possibility in heavy duty sector, heavy duty segment. Passenger car, the transition will be there, but globally, the fleet composition of electric cars, etc., is 4 to 5% only. Nepal is an exemption where the passenger car electric transition is very high, because Nepal has a very high import duty on ICE vehicles, but the import duty on electric vehicles is close to 20%. But on ICE vehicle, the import duty is 250%. So what has happened in Nepal? The cost of ICE vehicle and electric vehicle came at par. So you will see only in passenger car, only electric vehicles. But for heavy duty, the cost difference is very high, unless the 1/3 is the battery cost. So battery cost, unless it comes down, I think it will be a distant possibility. So, but recently the government of India scheme also focuses upon Euro 6. There is a subsidy for Euro 6 transition also. So if you see our fleet composition, then the composition like is still BS2, BS3, BS4 heavy duty vehicles are plying on the road. So they contribute the most. So even if they are transformed to BS6 by some incentive, by some regulation, by some enforcement, then I think it will solve the problem. So I think our focus should be more on BS6 or Euro 6. The China has done in the same way. They have implemented China 6, and that has yielded very good results in China.
And the last question, it is not a question actually, he is leaving the discussion point open from Veer Kumar. So 2 points he has raised. One is versus the use of electric scooter car and buses impact on air quality versus the disposable of lithium ion batteries, what will be used in these EVs. And second point, use of low cost sensor for air quality monitoring, especially in the Indian climatic condition, is expected and will be appreciated. So this is solution. The first is use of EV versus after some time the disposal of batteries.
Yeah. So I think government of India is doing great in bringing up like circularity, and also EPR regime is in all waste streams. Like for battery waste also, they have implemented extended producer responsibility in a very early stage. So I think this problem, when it comes, of course, electrical and electronic waste is a major problem in India. 80% of electrical and electronic waste is not processed in the formal sector. So that is a major problem. But for ecosystem has to be developed, and government of India is trying. And in developing countries, such challenges take some time to get settled. And his second point is of course the low cost sensors. We are doing exactly the same work. We believe in hybridizing three technologies and where low-cost sensor will also find its place.
Okay, so with this, now we came to the last uh, step of our this lecture, which is the vote of thanks. I would like to start vote of thanks by thanking you, Tiwari ji. Thank you so much
Thank
for
you very
accepting
much.
our invitation and giving such a wonderful talk. Thank you so much.
Thank
Then
you.
I also wish to thank our audience. Because of them, we are organizing this lecture. We will keep organizing these lectures. I request them to keep joining, keep interacting with the speakers. Means even otherwise, your lecture will be there in ASTA YouTube channel after now. But during this time, if they are joining,
Okay,
it is good time to interact with the speaker also. And I
right.
also wish to thank the whole team behind, means, arranging this lecture, which is at BARC or at Bombay. Everyone, thank you so much to you all. Because of you only, this is going on, and hopefully it will continue. So with this,
Thank you so much. Thank you so much, Dr. Neeraj, Dr. Sahu, Dr. Manish Joshi, and all participants for patiently hearing me. Sometimes I talk out of sentiments also, so just forgive me for that. Thank you very much.
thank you so much.